Section 11.1 to 11.3 quiz review worksheet that you have for homework. Remember, the quiz is tomorrow. Okay, the first question asks you to find the lateral area and the surface area for a regular decahedron. Now, a regular decahedron is a solid, okay, so that means it's a solid and its base is going to have those 10 sides. I can't really draw it very well, but it's going to have 10 sides. So the length of a side is going to be 10 and the height is going to be 15. So remember, the lateral area is equal to the perimeter times the height. So in this case, the perimeter, decahedron means 10 times the length of a side is 10 times the height, which is 15. That gives me a lateral area of 1,500. The next thing you have to do is find the area of a base, because if you're finding the surface area, you're going to use the lateral area plus 2 times the area of a base. So in order to find the base, the area of the base, that's 1/2 the apothem times the perimeter. To find the apothem, you take 2 radii and create that central angle, 360 divided by 10, which gives you a 36-degree central angle. Remember, the apothem bisects the angle and the side, and then we're going to create this triangle right here, which has an angle of 18 degrees. This was 10, so it bisected that side. That makes this 5 and allows me to find the apothem. Remember, I'm using trig ratios here, so tangent of 18 is equal to 5 over a. So a times tangent of 18 equals 5. So a is equal to 5 divided by tangent of 18. So the apothem is 18.7. Let me check to make sure I'm in the right mode. So 5 divided by tangent of 15.4 is the length of the apothem. So now, using the formula to find the area of a base, I have 1/2 15.4 times the perimeter. The perimeter is the number of sides, 10, times the length of a side, 10. So I get the area of a base is 0.5 times 15.4 times 10 times 10, which is 770. So now I'm going to write it up here. The total surface area is equal to the lateral area, 1,500, plus 2 times the area of a base, 770. So my total surface area for this regular decahedron is going to be the 1,550 plus 2 times 770, or 3,040. So again, the lateral area, fairly easy. Then you have to find the area of the base using 1/2 the apothem times the perimeter. To do that, you'll have to find that central angle divided by 2. Most likely, you will use the tangent ratio to find the apothem, and then you will be able to find the total surface area by using the lateral area and the area of 2 times that base. Okay, number 2, it's going to be essentially the same process. Again, you're looking at a regular pentagonal hedron, which means that the base is a pentagon. So I have this Sorry, my art isn't very good. The height is 12, the length of a side is 16. So again, the lateral area is equal to the perimeter times the height. So the perimeter, pentagon means 5, length of a side is 16, times the height, which is 12. So I have 5 times 16 times 12, which gives me a lateral area of 960 units squared. Again, to find the surface area, I need the lateral area plus 2 times the area of a base, which means now I have to find the area of the base. I have my central angle, remember that's 1/2 the apothem times the perimeter, which is going to be 72. The apothem bisects the angle and the side, creating this half of that central triangle, which means I have, this is 16, this is going to be 8, that's 72, so this will be 36, and you're looking for the apothem A. Again, the tangent ratio, tangent of 36 is equal to 8 over A, so A is equal to 8 divided by tangent of 36. 11.01, we'll just round it to 11. So now, to find the area of the base is going to be 1/2 the apothem times the perimeter, which is 5 times 16, or 80. That gives me the area of the base of 440. Now the total surface area is equal to the lateral area plus 2 times the area of the base. Lateral area we have as 960 plus 2 times 440, which is the area of the base, giving me a total surface area of 1,840. And all of the questions tomorrow actually have pictures already there for you, so you won't have to worry about trying to draw the pictures. They'll be there already. Okay, so the next one, find the lateral area and the surface area of the solids. Lateral area of a cylinder is 2 pi r(h). So in this case, 2 pi times the radius 3 times the height 8. So that gives me 48 pi. If you don't like, you can leave it as pi, or you can rewrite that as approximately 150.8. Then you have to find the area of the base. Remember, the base is a circle, so pi r squared. So that's going to give me 9 pi for a base, which is approximately equal to 28.3. Then my total surface area is equal to the lateral area plus 2 times the area of a base. So that's 48 pi plus 2 times 9 pi, which is, let's see, 66 pi, which is approximately equal to 207.3 for the cylinder. So remember, you're finding specific parts. You're finding the lateral area. You're finding then the area of the base. And you are finding then the total surface area. Okay. So on the next, when you're finding the lateral area, and I believe I actually put the instructions on the test, identify which base you're using when it is a rectangular prism as number 4. I will use this as my base. Remember, the bases just have to be parallel and congruent. And in a rectangular prism, you have 3 sets of parallel and congruent bases. So for me, the lateral area is going to be equal to the perimeter times the height. So the perimeter is going to be 4 plus 3 plus 4 plus 3, or 14 times 6. So that gives me a lateral area of 84 inches squared. Then the area of the base is just the area of that square on the bottom, 4 times 3, which is 12 inches squared. So then the total surface area will be 84 plus 2 times 12, or 108 inches squared. And these should all be units squared as well. Okay, let's go on to number 5. Number 5 is a pyramid. Remember, the formula for a pyramid, the lateral area is 1/2 the perimeter times the slant height. The slant height is this height right here. Okay, so I need to find the lateral area is equal to 1/2 the perimeter. Perimeter is, this is a hexagonal base, 6 sides. 6 times the length of a side, 6.5 times the slant height, which is 10. So that gives me 0.5 times 6 times 6.5 times 10, which is 195 centimeters squared. Then I have to find the area of the base. I'll do that up here. So the base, remember, is 1/2 the apothem times the perimeter. So again, I will take the central angle, so 360 divided by 6 gives me a 60-degree central angle. The apothem will bisect that, creating a 30, 60, 90 triangle. That's 30, that's 60, that's 90. The length of a side is 6.5, so half of that is 3.25. I need the apothem A. You can choose to use special right triangles and make A 3.25 root 3, or you can choose to use the trig ratios or the trig equations and set that up. I'll just go ahead and use the trig equation up here. So tangent of 30 degrees is equal to 3.25 over A. So A is equal to 3.25 divided by tangent of 30. That gives me an apothem of 5.6. So now the area of the base is equal to 1/2 the apothem, 5.6, times the perimeter, 6.5 times 6, which is 39. So 0.5 times 5.6 times 39 is 109.2. The total surface area of a pyramid is the lateral area plus 1 base. Lateral area is 195 plus 109.2, which is 304.2. Number 6, so all of this goes over here with number 5. Number 6 is a pyramid. This time it's a little easier because the base is a regular square. So to find the lateral area, I'm going to take 1/2 the perimeter, 4 times 6, times the slant height 9, which gives me a lateral area of 108. I have a base that is equal to 6 times 6, which is 36. And these are centimeters squared again. So my total surface area is the lateral area, 108, plus the base, 36, or 144 centimeters squared. Next, I have a couple of composite shapes. So when you look at number 7, and you're just finding the total surface area on 7 and 8, I like to break it down into the different pieces. So the first thing I'm going to look at is the bases. So in this case, we want to find the base, the area of this yellow shaded region. Okay. So each one of those is 1 inch. The diameter of this small circle, the diameter of this is 1 inch, which means the radius of this small circle is 1/2, and the radius of the larger circle is going to be 1.5 or 3/2. So in order to find the yellow region, the base, I'm going to take the area of the large circle and subtract the area of the small circle. And that's going to give me that base. So the area of the large circle is going to be pi times the radius squared minus pi times the radius squared for the small circle. So that's going to give me 9/4 pi minus 1/4 pi, which gives me 2 pi. So a base is 2 pi. Now I need to find the lateral area on the exterior. So I'm going to take the circumference times the height. The circumference is 2 pi times the radius. The radius of the large circle is 3/2 times the height, which is 6. So this becomes 18 pi. That's the lateral area, and we'll call that the outside. Then I have to find the lateral area of the inside. Think of a roll of paper towels. The lateral area of the inside is going to be 2 pi times 1/2, which is going to give me just pi. So now, to find the total surface area, I have the lateral area of the outside plus the lateral area of the inside plus 2 times the area of those bases. The outside is 18 pi, the inside is pi, and then 2 times a base, which is 2 pi. So that's going to give me 18 plus 1 plus 4. 23 pi is the total surface area of this solid. 23 pi. Again, look at the shape, determine what you have to find. You're going to have to find the area of the base and what constitutes the base. You're going to have to find the external lateral area and then the inside lateral area and add those together. Okay, number 8 and the last one. I have a composite shape, and that is made up of a cylinder and a cone. So again, think about the parts that constitute the surface area. You have a base that constitutes surface area. Then you will have the lateral area of the cylinder, and then you will have the lateral area of the cone. Not another base on top, because the cone sits directly on top of the cylinder. You can only touch one of those bases, so you're only going to include one of those bases. So we'll start finding the total surface area by finding the area of the base is equal to pi r squared. The diameter is 6, which means the radius is equal to 3. So the base is 9 pi. Then find the lateral area of the cylinder. Lateral area of the cylinder is 2 pi r h. So that's going to give me 2 pi times the radius 3 times the height 8. Gives me 48 pi. And now to find the lateral area of the cone, that's going to be 1/2 the circumference, 2 pi r, times the slant height. So when you look at the picture, you don't actually have the slant height. You have to focus on this triangle right here at the top. It has a height of 4. The radius of that circle is 3. So you'll use the Pythagorean theorem, 3 squared plus 4 squared equals L squared, and find the length of L, which is 5. So the slant height is 5. So the lateral area of the cone is, those will cancel, pi times the radius 3 times the slant height 5, which is 15 pi. Then the total surface area is equal to the one base, 9 pi, plus the lateral area of the cylinder, 48 pi, plus the lateral area of the cone, 15 pi, which is 72 pi units squared. And again, if you don't like leaving it in terms of pi, you're welcome to convert that. That's approximately 226.2 units squared. Okay? I hope this was useful. I'll see you tomorrow. Have a nice evening.